In this video, we're going to learn how to graph inequalities, starting with lines and then moving on to nonlinear graphs as well. So to start, we're going to test the following points to see if they're solutions to the inequality y is less than or equal to 3x plus 4. So I'm going to test 4, 5, just so that you know what I mean. So x is going to be 4, and y is going to be 5. So I'll write 5 is less than or equal to 3 times 4 plus 4. So 5 is less than or equal to 12 plus 4. I can see that's going to be true. And since it does work, I'm going to plot the point 4, 5, nice and big on my graph over here. I want you to go ahead and plot the rest of these points, please. Pause now. All right, so hopefully you agreed that negative 3, 1 does not work. Neither does negative 1, 8, but 0, negative 1, and 0, 4 both worked. This one right here, 0, 4, was interesting because it was, it ended up with 4 is less than or equal to 4, which is, you could think about that as being like kind of the boundary of what would work because it's or equal to, right? It almost doesn't work, but it just barely does because of that or equal to. So what we want to do is we want to find all of those boundary points. And hopefully it makes sense that those boundary points are going to be the ones that are right on the line y equals 3x plus 4. So we're going to go ahead and graph y equals 3x plus 4. We're trying to make a complete graph here because just 3 points that work is not enough. So we're going to start at 4, that y-intercept that's already been graphed. Then I'm going to graph my slope, which is 3 over 1, or up 3 over 1, to get my boundary line here. All right, that looks pretty good. And so all those points are going to work because if I put them in, I'm always going to end up with the number equals itself, which for this situation does work. So I'm going to draw on that line. And then we can see from the points that all the ones on this side over here, they were working, right? We found 2 of them. But the ones on this side over here, they didn't work, right? That's where negative 3, 1 was. That didn't work. Or negative 1, 8. That didn't work. So what we do when we graph inequalities is we shade in one side. So we shade in everything on the side that works, and we leave the other side unshaded. Sorry, my graph isn't very precise. When you're doing this on paper, it'll hopefully look nicer. You want to shade it in all the way to the edges of your graph and then stopping at your boundary line. Okay? Now, one more thing before we move on. What if instead of being this inequality here, there hadn't been that or equal to? So instead, it's been y is less than 3x plus 4. So it would be basically the same thing, except all the points on the line wouldn't have worked, right? It would have been the same shading, the boundary line would be in the same spot, but the points that are actually on the line wouldn't work because you would have ended up with a situation like 4 is less than 4, and that's not true, whereas this one is true, right? Doesn't work, does work. So in that situation, you would, instead of having a solid blue line, you would have a dashed line like that to show that the points that are actually on the line don't work, but that's where the boundary is. It's sort of like having an open dot versus a closed dot when you're doing a number line. All right, so I want you to try graphing y is less than x plus 5. So start by graphing the boundary line, decide whether it's solid or dashed, and then shade in the correct side. and check a point to decide which side to shade. See if you can do it. Go. All right, so hopefully you started by graphing y equals x plus 5, or at least putting down the points for it. Y-intercept at 5, and then slope of 1, so just over 1 up 1. Now, since it's just y is less than and not y is less than or equal to, I don't actually want to draw it all the way in. Instead, I'll do that dashed line like that. But I can still put arrows on either side because it will extend. Okay, and then I need to decide which side to shade. So if one point over here works, then all the points over here will work. If one point over here works, then all the points over here will work. So I'm just going to pick one to test. So I'm going to test 0, 0, just to see, because 0, 0 is easy. So 0 is less than 0 plus 5. That's true. This point works. That means it should be everything on this side. I'll test one more point, just to make sure though. Maybe I'll test -4, -2. So if x is -4 plus 5 is greater than -2. Well, that would be negative, or that would be 1 is greater than -2. Yes, that works. Okay, I believe it. And so now, for you, you're probably either using a highlighter for your shading, or you are using a pencil and just lightly shading. You do not want to shade it in so dark that you can't see the numbers underneath. You want to do light shading, especially because next week when we do systems of inequalities, you're going to do multiple of these graphs on top of each other, and you need to be able to tell which region has been double shaded. All right, beautiful. And I guess since we're still just learning this, I should point out that if you plug in something over here, right, it's not going to work. So you could test one of those too. So like -10, 10. If we do, let's see, y was 10. So 10 is less than -10 plus 5. Well, that would be 10 is less than 5. That did not work. So that's a no. So those ones, none of those on that side will work. All right, take a minute, look at this graph, and I want you to write down what inequality, what rule would give you this graph. Go. All right, so we're trying to write this in y equals mx plus b form. Y-intercept is -1. We can see that right here. And slope looks like it goes up 1 over 2. So rise over 1 says that would be 1/2. So y equals 1/2 x minus 1. And then we need an inequality. So it is a dotted line, which means it's not going to have an equal to. And this is where I want us thinking about like greater than or less than. So you may have noticed so far that on the last two examples, they were both less thans, and it was all the numbers below on the y-axis that worked. In this case, it's all the numbers above. So we're going to say that the y values are greater than 1/2 x minus 1. Because the y values above the line are shaded, so y is greater than. And we can just double check by testing a point again. So maybe we test 0, 0. So we see is 0 greater than half of 0 minus 1. Well, that's the same as saying that 0 is greater than -1. So yes, that's true. We did it right. All right, now let's try a nonlinear one. So in your homework, you're also going to do this for a parabola, but I thought in the video I would remind us how to do the absolute values, because that's something we haven't done in a while. So our strategy for absolute values is to make a table. Now the extension for this week is learning how to do this without needing to make a table first. So if you have the mental and space and time to do that, I encourage you to do it. For right now though, we're just going to make a table of x and y values and look for that spot where it turns around, because we know this is going to make a V, right? Not a parabola, but a V with a pointy top. So you're going to start by treating the inequality like an equation, and then just plug in your x value to find your y value. So for x equals -5, you should get y equals 1. Pause for a minute, go ahead and fill in the rest of the table. All right, hopefully you got these points, and literally all you're doing is just the same step I did for the -5 for each and every one. Maybe you can start doing them in your head, but that's the process. Okay, so now go ahead and plot those points on the graph, and since this has an or equal to, then it's okay to draw in the line. Do it now. And since just like a parabola, it's going to need to be symmetrical, you can, even though we didn't find the points for them, you can fill in those points on the other side and then draw on your line. Okay, and so then just like before, we're looking at this, we're going to see y is less than or equal to. So that does mean that the values below on the y-axis are going to work. But just to be sure, it's always good to test a point. I often test 0, 0, unless it's actually on the line. You never want to test a point that's actually on the line, right? Because that doesn't tell you anything. But 0, 0 is easy. So 0 is greater than or equal to the absolute value of 0 plus 3 minus 1. 0 is greater than or equal to 3 minus 1, which obviously does not work, and I now realize that's because I did this wrong over here. Oh, why can't I erase that? There we go. I don't know what I said before, but y is greater than or equal to, which means this should be shading up because 0 did not work. Oops. 0 did not work, so we are shading above the absolute value. Like that. And that's why we test. And so if you were doing this with a parabola instead of with a absolute value or with a exponential curve, anything, you would just first change it into a equation. So change the equivalent equation instead of the inequality, and graph that. You already know how to do those things. And then you would decide if it is solid or dashed by looking at what type of inequality it is, and decide where to shade by testing a point. It's really important that you test that point. And of course, those steps are true for lines as well. All right, for your practice problem, I want you to write the rule for this inequality. Take your time, be careful, good luck.